Good morning, everyone, and welcome to our channel Crypto Network. So, routing protocols define the set of rules used by a router when it communicates routing information between neighboring routers. Here, Enhanced Interior Gateway Routing Protocol (EIGRP) is a Cisco protocol and is very important because most popular routing protocols in use today. But now, since 2013, it is an open standard in order to help organizations operate in a multi-vendor environment. Now we will explore some of the features of EIGRP and then we'll describe how it works and how to configure it. So there are a number of powerful features that make EIGRP a real standout from other protocols and are listed here. Considered a classless protocol, same as RIP version 2 and OSPF. It supports for VLSM, variable length subnet mask, CIDR, efficient neighbor discovery, support for summaries and discontinuous networks, communication via reliable transport protocol, best path selection via diffusing update algorithm, dual, support for IPv4, v6, AppleTalk, IPX networks via protocol-dependent modules. Uh, Uses multicast address of 224.0.0.10 and IP protocol number 88. So before EIGRP routers are willing to exchange routes with each other, they must become neighbors. There are a number of conditions that must be met for neighborship establishment. And these are hello received, AS number, autonomous system numbers match, and identical metrics. Identical metrics are K values. So EIGRP routers that belong to a different autonomous systems don't automatically share routing information and they don't become neighbors though. This behavior can be real benefit when used in large networks to reduce the amount of route information propagated through a specific autonomous system. Here the only catch is that you might have to take care of redistribution uh, between autonomous system manually. So the only time EIGRP advertises its complete information is when it discovers a new neighbor and form adjacency when it through the exchange of hello packets. When it happens, both neighbors advertises all their information to one another. After each has learned its neighbor's routes, only changes to the routing table are propagated from then on. So you can adjust the hello timer per interface basis. Here in an example, we have serial interface 1/1. So we are changing the hello interval. So the command is IP hello interval, EIGRP, and then the EIGRP autonomous system number. Here 10 and 7. 7 the hello timer. So changing the hello timer does not automatically change the hold timer. So we have to change the hold time as well. So in order to change the hold interval, the command is IP hold interval, EIGRP, AS number, and 21. Simple as that. All right. So Enhanced Interior Gateway Routing Protocol, EIGRP, uses a complex equation to find the root metric value. EIGRP consider the following network performance related attributes to calculate the EIGRP metric value. So we have K values, bandwidth, K2 load, K3 as delay, K4 reliability, and K5 MTU. All right, so by default, the values of K and K3, K1 and K3 are set to 1, and values of K2, K4, and K5 are set to 0. Right. So the above equation is reduced, or you can say deduced, to EIGRP metric is equal to 256 multiplied by bandwidth plus delay. So bandwidth is the least bandwidth of all outgoing interfaces on the route to the destination network, and that is represented in kilobits, whereas delay is the sum of all the delays configured on the interfaces on the route to the destination network, and that is in tens of microseconds. All right, so here we have one example. The metric along the path to the destination 34.0.0.0 network can be calculated as we have we can verify the bandwidth and delay with the command show interface, the interface number, right? And here on router 1 we have show interface serial 1/0. So the bandwidth is 1544 kilobits per second, and delay is 20,000. All right. So let us calculate and verify. So our calculation is 256 into 10 to the power 7 divided by lowest bandwidth along the path. So lowest bandwidth is 1544 plus sum of all the delays divided by 10, and the delay is 20,000 per segment, per link. So 20,000, 20,000, 20,000, that is 60,000. So 10 to the power 7 divided by 1544 comes 6476, round off, plus 60,000 divided by 10, that comes 6,000. So if we calculate 256 into 6476 plus 6,000, the figure comes 3193856. And if you want to verify on router 1, run show IP route EIGRP, and D denotes uh, uh, the uh, the route learned via EIGRP. So 34.0.0.0/8, the metric is 3193856, confirmed via 12.0.0.2. All right. So this is simple practice required from all of you. Great. So EIGRP terminology. So the advertised distance is the metric for an EIGRP neighbor router to reach a particular network. So this is the metric between the next hop neighbor router and the destination network. The feasible distance is the sum of the advertised distance for the particular network learned from an EIGRP network plus the EIGRP metric to reach that neighbor. In simple, the cost between this router and the next hop router plus the distance, or the distance of advertised distance, sums up the feasible distance. From the perspective of each router, the best path learned through EIGRP to a destination network is known as the successor route. Feasible successor. So feasible successor is a backup path to reach that same destination that can be used immediately if the successor route fails. These backup routes are stored in the topology table. For a route to be chosen as a feasible successor, one condition must be met. And the condition is a neighbor's advertised distance AD value. Do not confuse with the AD value, the administrative distance. This is the advertised distance we are talking about. So a neighbor's advertised distance for the route must be less than the successor's feasible distance. This condition must be met in order to be chosen as a feasible successor. All right. So a router running EIGRP maintains three tables. The EIGRP neighbor table contains the known EIGRP neighbors the local router is directly connected to. For example, uh, we can look at router 1 neighbor table using the command show IP EIGRP neighbors, and we can see the IP addresses of adjacent routers. Next, EIGRP topology table contains everything that EIGRP has learned. Now, the routing table holds the best routes to each destination, and is used for forwarding packets. Successor routes are offered to the routing table. By default, up to 4 routes to the same destination with the same metric can be added to the routing table. And guys, please watch EIGRP protocol part 2 for rest of the topics.